6 eruptions in under 10 hours, ash turning from gray to black. Anak Krakatoa is now at level 3. In 2018, this volcano killed 437 people, and not one person felt the ground shake first. In 1883, it killed 36,000, and the overwhelming majority of them did not die from the fire. They drowned, and 8 days before this volcano escalated. Venezuela's ground moved 2 feet sideways, permanently. That connection between 2 disasters on opposite sides of the planet is the story nobody is fully telling you. The date is July 14th, 2026. 2 geological events are being read together for the very first time. On June 24th, Venezuela's M7.2 and M7.5 doublet sent seismic energy radiating outward across the entire planet. 8 days later, Indonesia raised Anak Krakatoa from level 2 to level 3 and widened the exclusion zone. Scientists have documented a phenomenon called dynamic stress, triggering a distant major earthquake loads a volcanic system. The 2004 Sumatra M9.1 earthquake triggered documented volcanic unrest in systems thousands of miles from the epicenter. Venezuela's doublet was smaller, but its seismic waves circled the Earth and hit every loaded system they found. Drop your city below is your coastline within reach of a Pacific tsunami or a volcanic system. Whether Venezuela triggered Krakatoa's escalation cannot be confirmed, but the timing is not something to dismiss. What we can say is both events are expressions of the same tectonic forces that never stop loading. So let us walk through the full picture of what happened, why it matters, and what your city should know. In early June, satellites detected the first warning sign, a spike in sulfur dioxide gas above the crater. Alongside it, a thermal anomaly appeared where the surface was hotter than it had any reason to be. That combination, gas plus heat at shallow depth, is one of the earliest fingerprints of magma moving upward. On June 10th, a distinct hotspot appeared directly inside the crater, visible to infrared instruments on orbiting satellites. Between June 16th and July 2nd, instruments recorded 740 exhalation earthquakes and 520 hybrid earthquakes beneath the island. 16 separate stretches of continuous tremor ran through the volcano's internal plumbing during that 3-week window. That is not one event, that is a volcano breathing faster and faster, week after week, without pausing. Then, on June 26th, the ash changed color, and that color change is the detail that changed everything. White ash is mostly steam, a volcano quietly exhaling on a calm day with nothing dramatic happening below. Gray ash means solid fragmented rock is being carried out with the gas magma is near the surface. And on July 2nd, the ash darkened to black. The system stopped venting and started tearing rock apart. At 2:05 in the afternoon, a column of black ash punched 200 meters above the crater and leaned northwest. The seismograph recorded a 23-millimeter spike lasting 20 seconds, the signature of a fully pressurized system releasing energy. Less than 3 hours after that eruption, Indonesia's agency moved the alert from level 2 to level 3. The exclusion zone widened from 2 to 3 kilometers, nearly 2 miles of open water sealed off around it. That alert level shift is not a forecast a computer generates automatically without human judgment behind it. Raising an alert level shuts down fishing grounds, tourism routes, and major shipping lanes through the Sunda Strait. Agencies do not raise alert levels casually. Every step up carries real economic costs and public visibility. When Indonesia moved Anak Krakatoa to level 3, that single, costly decision stated clearly that risk had genuinely climbed. And then July 8th happened, and the escalation became something impossible to look away from. In under 10 hours on July 8th, the volcano erupted 6 separate times from the same pressurized crater. The first came just after midnight, a seismic amplitude of 24 millimeters, lasting 40 seconds in complete darkness. By 7 in the morning, that seismic amplitude had climbed to 44.4 millimeters, nearly double the midnight reading. The volcano was not just erupting more often, each burst was hitting harder than the one before it. Ash columns reached roughly 250 meters above the summit, and the color sequence ran white to gray to black. Black ash means the system stopped merely venting gas and started tearing rock apart and throwing pieces upward. The Darwin Volcanic Ash Advisory Center tracked the ash cloud at 15,000 feet using the Himawari 9 weather satellite. That ash drifted southwest across the strait at altitudes that immediately triggered aviation advisories for the surrounding region. Ground observers saw a modest plume above the crater. The satellite saw that same plume spread miles away. The observer sees smoke leaving the chimney. The satellite sees that smoke spreading across the neighborhood minutes later. Both instruments tell the same story. This volcano is actively, persistently erupting, and ash is reaching significant altitude. As of July 14th, the alert holds at level 3, and the southwest flank remains under active watch. After the July 8 sequence, the volcano showed some easing, tremor quieted slightly, and plumes decreased in intensity. But easing at a volcano that was still inflating days earlier is not resolving it, is a pause. Now here's the part that separates Anak Krakatoa from almost every other erupting volcano on Earth right now. It is not the ash column 250 meters is modest by volcanic standards and would not normally alarm anyone. The danger is what this volcano physically is and exactly where it sits in relation to millions of people. Anak Krakatoa is not a mountain with a crater on top, sitting safely on solid land somewhere remote. The entire island is the volcano, a loosely built cone of fresh rock rising straight from deep ocean water. It sits in the Sunda Strait, the narrow channel separating the Indonesian islands of Java and Sumatra. On both sides of that strait lie densely populated coastlines, fishing communities, resort towns, and major ferry routes. This is not a remote peak in empty wilderness. It is a live volcano in a crowded, populated strait. The deep danger here is not upward. It is sideways and downward through the water surrounding the island. This island slope does not stop at the shoreline. It continues underwater, dropping into deep, open ocean below. The cone is built from poorly consolidated rock, the same material that failed catastrophically in 1883 and 2018. Since 2018, the volcano has spent years rebuilding that same unstable shape on the exact location it previously failed. Picture the difference between a granite mountain and a mound of loose gravel poured onto a steep ocean ramp. The granite holds its shape under enormous pressure. The gravel just waits for a reason to slide. Under continued eruptions, rising magma pressure, or earthquake swarm shaking, that loose structure can give way suddenly. And when it gives way into open ocean, the ocean does not absorb it. The ocean moves sideways. That movement becomes a wave, not the kind any conventional tsunami warning system is designed to catch. This is the chain reaction that keeps volcanologists watching this island more closely than almost any other on Earth. An eruption continues and loads fresh, unstable material onto an already steep cone, rebuilding on a previous collapse scar. That loading destabilizes the southwest flank, the same flank that failed in December 2018 and killed 437 people. A section of the island breaks away and slides into the Sunda Strait, displacing an enormous volume of water. That displaced water races outward as a tsunami not triggered by a fault rupture, but by a collapsing mountain. A tsunami with no fault rupture, and that single distinction is the most important fact in this entire story. Every tsunami safety protocol ever taught to coastal communities worldwide starts with the same fundamental trigger. If the ground shakes hard near the coast, move to high ground. The shaking buys you minutes to survive. Minutes that have historically saved thousands of lives from Japan to Chile to the Indian Ocean coast in 2004. A volcanic flank collapse removes that alarm entirely. It goes from collapse to wave with nothing in between. No extended ground shaking, no obvious physical cue. Nothing for the human body to recognize as incoming danger. The wave simply arrives, and when it does, the only question is how far inland it travels before stopping. That is the unresolved warning problem that the 2018 disaster made impossible for monitoring agencies to keep ignoring. Can monitoring of shallow earthquakes, gas readings, thermal signatures, and ground deformation catch a flank collapse in time? Or is a silent volcanic tsunami simply a hazard that moves faster than any warning system can respond? These are not theoretical questions from a classroom. This volcano already ran the real experiment on a real coastline. The result of that experiment is why anyone treats a small gray ash plume here as a serious event. It is also why Venezuela's doublet, 8 days earlier, adds an urgency that is hard to dismiss entirely. That earthquake sent seismic waves through an already loaded volcanic system that was already building towards something. What those waves did or did not do at Krakatoa underground is a question the July data will answer. On December 22, 2018, this exact chain reaction played out in full on a real populated coastline. An eruption destabilized the southwest flank. Roughly 0.2 cubic kilometers of volcanic material slid into the Sunda Strait in a single night. The volcano dropped from 338 meters to just 110 meters, losing 228 meters of height. Think about what that means. A mountain lost the equivalent of a 74-story building in one sliding event. There was no large preceding earthquake, no ground shaking that anyone standing on the coast could feel or recognize. The collapse displaced an enormous volume of seawater and sent a wave racing toward both sides of the strait. It arrived between 9:30 and 10 o'clock at night, in complete darkness during holiday season when beaches were packed. People had no cue that anything was happening, no physical signal, no training that told them to run. At Kurita, water reached 6.6 meters and pushed nearly 250 meters inland, one of the smaller waves that night. At Sumo, the run-up hit nearly 15 meters, cutting the area off from outside communication for 3 full days. Waves along the populated coastlines of Java and Sumatra reached approximately 13 meters, better than 40 feet in places. The first sign of the tsunami for most people in its path was the tsunami itself arriving at them. At least 437 people were killed, more than 14,000 were injured, and tens of thousands lost their homes overnight. The number that defines that night is not 437, not 14,000, not the wave height, and not the darkness. The defining number from December 22, 2018 is 0 earthquakes large enough to trigger any warning system. 0 felt earthquake warnings. That is how many the communities in the wave's path received before impact arrived. That is the cruelty of a flank collapse tsunami and why this volcano gets its own risk category. Warning systems across Indonesia and the Pacific had been built around one core assumption: the ground shakes first. On December 22, 2018, that assumption failed, and the Sunda Strait communities paid the price directly. Every tsunami safety rule ever written for coastal communities assumes the ground warns you, and here it did not. That gap between the real threat and the systems built to catch it is the wound 2018 left behind. The 2018 disaster is the recent proof, but it carries the shadow of an event 135 years earlier. In August of 1883, the original Krakatoa erupted in one of the most violent volcanic events ever recorded. The explosion was heard approximately 1,900 miles away in Perth, Western Australia, one of the loudest sounds documented. The pressure wave from that eruption circled the entire planet multiple times and registered in London and Washington, D.C. At least 36,000 people were killed, the overwhelming majority not by lava, not by ash, not by the explosion. They drowned the largest waves in nearby bays reached 40 meters, the height of a 13-story building. The eruption rated VEI 6, classified as colossal, threw enough sulfur to cool the entire planet. The lesson written in 1883 and repeated in 2018 is the same lesson in the same stretch of water. In the Sunda Strait, the real killer has never been the fire. It has always been the water. This system is not just an Indonesian hazard. It is one of the most documented chain reaction threats on Earth. Drop your city below. Does your coastline face Pacific Basin tsunami risk from this part of the world? A volcanic tsunami generated in the Sunda Strait travels outward across both the Indian Ocean and the Pacific simultaneously. Hawaii sits roughly 8 to 10 hours of wave travel time from the Sunda Strait across open Pacific water. 8 to 10 hours sounds like enough warning until you remember 2018 generated no detectable seismic alert at all. The entire warning gap from 2018 exists because the trigger was a collapsing mountain, not a rupturing fault line. For the U.S. Pacific coast, California, Oregon, and Washington all carry calculated tsunami hazard from Pacific Basin volcanic events. A flank collapse tsunami from Indonesia disperses over distance but still poses a real hazard for West Coast cities. Seattle sits above the Seattle Fault, faces Cascadia subduction offshore, and its downtown is built on soft bay fill. Los Angeles has the San Andreas, soft basin soil. And now a reminder this week that the Pacific stirs. Portland faces Cascadia from offshore and sits within the Pacific tsunami risk zone like the rest of Oregon's coast. Hawaii faces the additional exposure of being directly in the path of any Pacific crossing wave from the Indonesian region. Within the U.S., volcanic systems sharing similar island and coastal characteristics deserve a direct mention this week. Kilauea in Hawaii is an active volcanic system beside populated coastlines that has previously generated locally damaging tsunamis. Mount St. Helens experienced a catastrophic flank collapse in 1980. The same physics, but no open ocean beside it. The 1980 collapse generated no tsunami because St. Helens is not marine, but the mechanism was completely identical. Mount Rainier, near Seattle, carries a related threat, lahars, that function as the land-based version of a flank collapse. The Cascadia subduction zone, covered in a prior episode, connects to the same ring of fire as Krakatoa. All of these systems are links in the same chain that includes the Sunda Trench and Venezuela's fault zone. None of this means a U.S. volcano moves next week. It means they share the same restless tectonic parent. Which region do y'all want us to break down next? Pacific Northwest, Gulf Coast, Hawaii, or the Caribbean? Tell us in the comments. We will go where the data says the most important story needs telling. The global pattern emerging in 2026 is not coincidence. It is the planet expressing decades of accumulated loaded pressure. Venezuela reminded us the Caribbean plate is not done. Krakatoa is reminding us the Sunda plate is not done. Both are on the same restless planet, and the water between them is paying very close attention right now. Drop your city one more time and tell us what threat has your community never been properly briefed on. Scientists watching Anak Krakatoa right now have identified exactly what signals would change this situation significantly. Level 4, called Awas, would follow sustained black ash, intensifying tremor, or visible lava at the crater rim. Level 4 is Indonesia's top alert. It means a major eruption is already underway or considered genuinely imminent. On July 14th, the alert holds at level 3, and monitoring shows slight easing since the July 8th sequence. The tremor has quieted somewhat, and the plume has dropped from black ash to a lower gray haze. But quieting at a volcano that was still inflating days earlier is not the same thing as resolving. At a volcano that kills without erupting, silence is not reassuring. It is a question, not an answer. Is Anak Krakatoa winding down, or is it catching its breath before the next eruptive sequence begins? The answer lives in one specific data stream, deformation measurements on the southwest flank of the island. Any measurable swelling, tilting, or downslope movement on that southwest sector immediately changes the entire risk calculation. That is the single most critical measurement right now, more important than ash color, tremor, or plume height. The current cone is lower and less massive than the one that failed in 2018, which lowers probability somewhat. But lower probability is not zero probability. And at this specific volcano, the tail risk gets its own category. Continued monitoring is not fear. It is the honest response to a system that proved its worst case twice. The monitoring happening right now is also a live test of the warning improvements implemented after the 2018 disaster. 3 claims circulating online about this eruption deserve a direct answer before we close. First, this unrest is triggered by a directed energy weapon or secret atmospheric modification technology somewhere. The energy involved in moving molten rock through a subduction zone dwarfs anything human technology can produce. Second, authorities are hiding an imminent mega eruption, but the public alert level is the public communication. Third, solar activity or planetary alignment is driving this eruption, but no established mechanism links those to magma movement. The genuine documented danger here is frightening enough on its own. It needs no exotic explanation to take seriously. The honest position, as of July 14, 2026, sits between two different mistakes that are equally worth avoiding. Dismissing this as just a small plume ignores a documented history that demands serious ongoing attention. Catastrophizing, treating level 3 as a guaranteed repeat of 1883, is wrong and unsupported by the current data. The correct posture is the one scientists actually watching this mountain around the clock have taken vigilance without panic. Drop your city one final time and tell us what geological threat your community has never been briefed on. 6 eruptions in 10 hours. Ash going black. Amplitude nearly doubling. Islands still rebuilding on a collapsed flank. Venezuela proved that 2 faults slipping 39 seconds apart moves the ground 2 feet permanently. In 1883, 36,000 people did not die from fire. They died from what the fire did to the ocean. In 2018, 437 people did not die from an earthquake. The earthquake simply never came to warn them. As of this week, monitoring continues, the exclusion zone holds, and the southwest flank is under active watch beneath the Sunda Strait. A volcanic system that proved its worst case twice before continues building pressure. 8 days after Venezuela's coast moved permanently, a volcano across the Ring of Fire escalated to level 3. Whether those events connect by physics or timing, the pattern they form together is the one worth understanding. The planet does not wait for better warning systems before deciding what to do with a loaded fault. It loads, it builds, it waits, and when it moves, only time stands between the wave and the shore. At Anak Krakatoa this week, scientists are not measuring the ash. They are measuring the water's silence.